In this video, we're going to derive a formula for the area of a regular polygon. A regular polygon, recall, is a polygon whose sides are all congruent and whose interior angles are also congruent to each other. Here's a diagram of a regular hexagon with some important parts labeled that we're going to discuss briefly here. In the next video, we're going to use these formulas that we come up with to solve some problems to find the areas of these sorts of things. A few terms that you should know are here, and I've already filled them in, so I'll just briefly talk through them and point them out in the diagram. We say that the center of a polygon is the center of a circle that circumscribes this polygon, meaning the circle goes through each vertex. In this picture, point P is the center. This circle has a radius, so we also say that the radius of the polygon is the distance from the center to any one vertex. So in this case, PM is a radius of the circle, PN is a radius of this polygon. And apothem, or apothem, depending on how you choose to pronounce it, is the distance from the center to the side. And we always measure distances at right angles. So in this picture, this blue segment from P to Q is an apothem. And then lastly, we're going to find central angles of polygons. And these central angles are angles that are vertices on the center. And it's the angle that you would make by connecting consecutive or vertices to the center, or vertices that are next door to each other. So in this case, angle MPN would be a central angle. With these things in mind, we would like to try to derive a formula that calculates the area of a regular polygon. Meaning, I'd like to know just on the characteristics of that polygon, meaning how many sides it has, or what the length of a side is, or what the length of an apothem is. By just knowing those things, I would like to be able to use that to calculate what the area of one of these regular polygons happens to be. And I've outlined, I think, a good strategy or game plan for doing this. Our game plan is going to be as follows. We're going to start by dividing our regular polygon into triangles, starting originating from the center. So I've kind of drawn one in up here, but you can imagine drawing in these radii out so that I subdivide this thing into triangles. These triangles are all congruent to each other. They're all congruent by side angle side. So I can turn this more complicated problem of finding the area of this regular polygon into a little bit simpler problem of finding the area of one triangle and then multiplying by how many triangles there are. And there are the same number of triangles as there are sides. So if I can break this problem into finding an area of a single triangle, then I can find the area of the polygon just by multiplying by that value. Also, recall that we have two area formulas for finding the area of a triangle. We have the classic one, 1/2 base times height, which means that if you look at a triangle, we would need to know its height and the length of a side of that triangle, called the base. Note that in this picture and in our original diagram that the base corresponds to the length of one of the sides. And this height is the distance, if you think of this top corner as the center of the triangle, then this height is the distance from the center to the side, which we just gave a name. It's called the apothem. So one triangle formula could be, the area for this triangle could be 1/2 a side length times the apothem. Alternatively, we saw when we, in our lesson on the law of sines, we saw a different way to calculate the area of a triangle, that you didn't need to actually calculate a height, but instead all you need to know are two sides and the angle in degrees of the angle that's included in between them. From this point of view, if I look at my triangle here, if I think of this top corner as the center of this regular polygon, that each of these sides would correspond to a radius of this regular polygon. And this included angle would be the angle in between these two radii, which happens to be this central angle. So it looks to me like we could find two different formulas for the area of a regular polygon based on each of these two methods for finding the area of a triangle. And I've summarized them down here. So one method, the kind of more classic method, is using an apothem and a side length. So I could use this 1/2 base times height, where the height is just this apothem length, and the base is a side of the right triangle. So if I do 1/2 apothem times side, that gives me the area of one of these little triangles I've created, like here. And then I multiply by how many of these triangles there are. In this case of a hexagon, there are 6 of them, so n would be 6. Or I could take the point of view of this more general approach, where I have two sides and the included angle in between them, where I could think of the two sides being the length of radius of this regular polygon, and the included angle between them is just one of these central angles. So I could do 1/2 times side times the sine of the included angle would be the area of one triangle. And then I multiply again by n, which is how many sides there are, which is the same as how many of these triangles there are. You could simplify this formula a little bit. R times R is R squared. So putting with those two things in place, we can, so depending on what information you have to start with for your regular polygon, that should guide you to determine which of these two formulas will be the easiest to use and the most simple to apply. If you're willing to do a little bit of trigonometry, you can always use the same formula every time. But it may be more flexible and maybe more useful for you to kind of think of each of these two things and try to decide when to apply each of them based on what information you're starting with, whether you know an apothem and a side, or whether you know the length of a radius and calculate the central angle. In this next video, we'll take these two formulas and apply them to solve some problems.